So where's Mika standing? At the ground between two buildings. We know that one building is higher than the other because that's what it says, right? So if I draw two buildings, right? So if I have building one, I know that's higher than the other, right? So it doesn't have to be higher anyway, but it doesn't say that anywhere. So Mika stands between the two, but we don't know if she's in the middle or not, right? So let's put this as Mika. It's not in the middle, right? It doesn't have to be. Now, if you're looking at the top of the first building, it's 152 meters from Mika at an angle of elevation of 38 degrees. So, where would that be? What do I have to draw now?
From the bottom
From Mika to
the
the top, and that's going to be what? How much is that going to be? 152. And since it's an angle of elevation of 38 degrees, where would that be? This one? Right? Because that's where she's standing. Angle of elevation is measured from the horizontal up. What?
Could I try it the other way around?
What do you mean? Well, where's the other building?
So this is one. This is one.
Oh, where's Mika standing? When? At the bottom of the first building?
Yeah.
That's not what it says, right? It says that Mika is standing on the ground between the two buildings. Okay? Now, the top of the second building is 175. So what do I draw now? A line from Mika to the top of the building, right? And how high is that? And at an angle of elevation of 53 degrees. So the angle right here is 53 degrees. And the question is asking you, how far apart are the top of the two buildings? So what am I looking for? I'm looking for this side. So the top of the two building, I'm looking for this. Okay. So if you were to solve this, what would you do?
Here's two sides.
So I have two sides. Yeah. I find the contained angle. So I find, you mean this angle right here? Okay. And how can I find this angle right here? That's right. Because if you're looking at the whole thing right here, this whole thing, that is 180 because that forms a line. Okay? So if you're looking at a line is actually 180 degrees. Right? So I know two of the angles, then to look for the third one, I just have to do 180 minus the other two. So this is angle, we're going to call this angle A. So to find angle A, we have to do 180 minus 53 minus 38. And what do you get there? 89. So now you know that this angle is 89, and you know the two sides. What law, or what do I use? Cosine law. And because I have two sides and the contained angle between them. Okay? So I can use the cosine law. I'm looking for side A. Yeah? So let's call this B, let's call this C. So this is side B, and this is side C. I'm looking for side A. So I'm going to use the formula a squared equals to b squared plus c squared minus 2bc cosine angle A. I know side B is 175. I know side C is 152. And I plug in everything where they're supposed to go. Remember that when you do that, you have to make sure that you either do each one separately or you have to enter it all together as you see it on the calculator. Both of them, just so you see if you actually can do it all together, because then it's easier. But some calculators, if they're backward, you can't unless you know how. Is that my final answer? Are the two buildings 52,800? So what do I have to do?
Must be inverse.
Square root.
Square root.
Square root, because I have a squared, right? Because I have a squared, to get rid of that square, I have to square root. So the square root of both of these is 229.8 meters. So your therefore statement has to be the top of the buildings are 229.8 meters apart. So you guys write that, don't write dot, dot, dot.